Hey guys, so today we're going to be doing a 2JZ-GE VVT-i from an IS300 going into an Altezza RS200. So, let's get into it. Right, as I said, this is going to be a 2JZ-GE VVT-i from an IS300 going into a Toyota Altezza, the RS200, which originally came with a 3S-GE, and that was a 98 to 2001 model. So as you can see from looking currently, it is a tape-up job, as I call it. Basically, we take the original harness, because it runs in the same way that an Altezza would. We take the original harness, we completely strip it down, remove all the existing covering, recover all up, remove everything it needs removing, add in what does need adding to make it plug and play. So first thing we're going to do is let's cut to a couple of photos to show you what that process looks like when we pull everything apart and put it all back together again. Right, so there you go. You can see basically just pull everything apart and then obviously remove everything that not needed, add in what needed adding, and then cover it all back up again. So what we're going to do today is the same as usual. We're going to first go through the layout of the harness. So we're going to go and show you where everything connects in. With the 2JZ model, because obviously the intake goes over the top, I take the intake off to do this first section to show you where everything goes. And then obviously when we come back into the rest testing, the intake's back on again. And I go through those little sections that are plugged in with the intake on. Then what we're going to do is we're going to do the testing of the harness, and that's obviously going to be with the engine, just the ignition on. So there's a couple of things we test there, and obviously with the engine running as well. So you can see that everything is running nicely before we send it out to the customer. Make sure everything's 100%. Obviously we do a short little bit of running here, but we run it full up to temperature, get the coolant fans running, and the whole 9 yards before we do the video as well. Okay, so let's start over here by the ECU box, and obviously I just want to this is an IS200 half cut. So you can see here we go from IS200 to Altezza and then to the patch section that's going to actually interface with the IS300. So in the customer's car, his plugs here are going to plug directly into there. This is going to be not there basically because his is an Altezza, not an IS200. Okay, so it does look a bit messy, obviously. What I'll do now is I'm going to cut to a photo of what it looks like when it's actually all nicely plugged in. There you go. So you can see once it's all nicely plugged in, everything's tucked away, really nice and neat. The lid just goes straight on, no dramas whatsoever. All right, so let's go through with what actually gets plugged in here. So first of all, we have our ECU plugs, 1, 2, 3, 4, and 5. So again, really nice and simple and straightforward. We then have what I call our patch resin section that interfaces with the 2 existing plugs in the Altezza, and that then goes to the 2 body plugs that are there. A couple of extra wires that go to the body plugs over there that would normally go through the car in the IS300, but again, they are over there. Then we have this, which you won't normally see on our IS300 swaps, and that's basically because the Altezza requires a 4-cylinder signal, not a 6-cylinder signal. So this is actually going to change the signal so it matches on the cluster as well. Unfortunately, I only have IS200 clusters, so I try my best to get it, but I do have a video on how to adjust this box here. So again, it's super nice and simple. Basically, all you do is pop off this lid here. You have a little potentiometer over there. You can plug in a diagnostics machine like you'll see I'm going to do there. I'm going to use my laptop, and you can actually check the RPM on there, and obviously you can adjust this to then match your cluster correctly. Okay, so again, super simple, straightforward, no dramas whatsoever. Okay, then in terms of the body section, we have only 3 connectors here, and that's this blue one, this gray one, and this white one. Now in the Altezza, this frame will be white, so it actually matches up. Obviously it's black in the IS200, okay? But again, all 3 of these plugs are unique. You can't plug them into the wrong place, so you don't stress about that. And same applies to all of these ECU plugs, and same applies to these plugs over here. All different, so you can't get them in the wrong place. Right, and then we have our little junction box over here, and that clips in directly over there. So again, super simple and straightforward, no dramas there whatsoever. There is one little section down the bottom here that you haven't seen yet, and that is a relay, okay, and that's for the brake switch. Now, obviously, the IS300 had a 4-wire brake switch that gave a signal both when the brake was not pressed, and when it was pressed. So we are imitating that because the Altezza doesn't do that with this relay over here. So that's going to imitate a 4-wire brake switch over there. Okay, so that is the ECU box. Really nice and simple, nothing too major there. Moving along, we then have our grommet, and that's going to obviously slot down into there. As you saw in the previous photo, that's obviously slides directly into there. It's a rubber grommet, so when you put the lid on, everything seals. Okay, and before I move completely away from here, what you will notice is on the Altezzas and the IS200s, they had a rectangular ECU, not this wedge-shaped one. So if you are using that particular box, there's 2 options for you. One, you can just undo these 4 screws here. There's one there, one there, one there, and one there. Literally pull out the PCB. Obviously, you don't want to generate heat for it. And you can take a grinder and you can grind this lip off over here, and this will actually slot all the way down there. Unless you have an IS300 ECU box, in which case this is designed for that. So again, it'll slot directly in, and the IS300 ECU box will bolt straight in place of the Altezza or the IS200. So again, those are basically your 2 options there, but both of them relatively simple. One angle grinder is, hopefully you've got one lying around, you can just grind that lip off. But if you do have access to a box, grab that, bolt it in, and Bob's your uncle. Okay. Right, so moving along there, we then have our first breakout, which comes over here, and that goes over to our igniter. So the igniter is going to mount on the strut top here. So again, it just requires an earth from that. So bolt straight in there, no problems at all. He's still got the original bracket on here. This is the customer's, obviously, igniter, because we asked them so we can test the engine with them. So again, that'll bolt straight onto there. Moving along from there, and then we have these section that's going to go into this plastic section over here. So again, these little plastic sections sort of keep everything together. They can bolt down to the engine, and so keep everything nice and neat. So from here, it splits in actually 3 directions. We're going to go over the top there, we're going to go around the back there, and we actually go straight down as well. So while I'm at this angle over here, let's go straight down and see what comes out the bottom over there. So hopefully you can see there, that's where it all comes out down the bottom over there. And it splits off about here, and there is actually 2 sections that break out. So you can see I'm holding my finger on one, and there's another one at the back there. This section that breaks off over here is going to come down and go to the power steering pressure sensor. Okay, now do bear in mind on IS200s, and I'm pretty sure the Altezza as well, they didn't have a power steering pressure sensor with a 3-plug. They actually had a pressure switch that was only a single wire one. Now, if you're not going to change the lines for an IS300, the power steering lines, okay, that would normally obviously run out of here and down there, then what you can do is you can take the old IS200 manifold pressure sensor and just plug it in. It just gets rid of the code basically for it. But if you do actually fit the line, then this will have a place to plug in. And obviously what this is for is to measure the power steering pressure. Now, you'll probably realize that the reason they want to know that is obviously when you are on full lock, for example, it'll actually pick up the RPM a little bit. If you plug this in, it's not going to actually know what the pressure is. It's going to think there's no pressure all the time, so it's not going to pick up the RPM when you are on full lock. So do bear that in mind. It's not necessary. I've never had any issues with just doing this. If you want that feature, you do have to fit the IS200 lines and fit the pressure sensor that's going to go in there. Okay. The other one that comes out of this section over here, which is really, really straightforward, is going to be your alternator cable. Okay, and that's going to bolt in directly over there. So again, super nice and simple. M6 nuts on there, so 10mm socket, that just comes off. It's got a whole plastic frame in there, which you'll see at the end of the video. I've got photos of the whole harness out there. You'll see there's a plastic frame around here, and that slots into this fuse box, and it actually, you have to push these little clips in there and there to then slide it out once you've unbolted it there. Now, quick little note, if you've watched a couple of our other videos, actually including the main alternator cable is only in the IS300. They don't do it in the IS300 2JZ-GE VVT-i. So slightly nice on the IS300 ones because obviously it does include that, so your whole harness comes complete, but obviously on the GS300 ones you don't have that functionality. That's not how they did it in the GS300. Okay, right, so moving along here at the back here, it's going to be a bit tough for you all to see, but it goes down over there and it breaks off about there, and the first point it goes to is the coolant temperature sensor. So that's a little black connector that you see over there. Down here you can see we have a NOx sensor plug. That's that white one over there. Also comes off to go to the oil pressure switch. Now, because this is an Altezza, what the customer's going to want to do, especially because it's an RS200, I must stress that, on the RS200s they had an oil pressure gauge on the dash. So he's going to want to take this oil pressure switch, which is just an on and off switch, out and replace that with a oil pressure sensor from an Altezza RS200. For your interest, it's the same pressure sensor that comes on a Land Cruiser. So you can, if you've got scrapyards near you with Land Cruisers in, you can go and grab one of those sensors from there and they work absolutely fine. Okay. And then moving on down here, we then have our aircon plug. which that goes directly into there like so. So we obviously tuck that behind the aircon over there. And then lastly, we have our low oil level sensor, which goes into there. And I don't think, if I remember correctly, that the Altezza had a low oil level sensor on. But of course, because it's an IS300 harness, we are leaving this completely intact. So again, this could be used again on an IS200 if you wanted to. We could actually adapt this harness and make a little small section like that and change a couple of the body plugs around, and it would work on an IS200. Okay. So again, then you swap the switch out for the, you swap the pressure sensor out for the switch, and then it could work on an IS200 as well. Right. Okay, so that's that section that goes down over there. Really nice, simple, super straightforward. What I'm going to do now is, because I'm on this side of the car, let's make our way down here. So again, you can see the plastic bolts down over there. Okay. And again, little section where we taped up over here. This one over here is the oil control valve for the VVT-i solenoid. It does actually come out there, but I tape it down over there. That's how to run it as standard, okay? Then we have injector 1, that comes out over there. We then have injector 2, that also comes out over there. We then have our TPS, which again, this is gonna go on the throttle body. So you'll see that when the throttle body goes back on again. And we have our noise filter. So there's a little noise filter on the actual throttle body itself. So it's basically this thing over here. Okay, where your harness clips in as well. That's a little clip for your harness over there. That obviously goes into that thing over there. It's basically a capacitor. It's designed to absorb noise from things like the coils and the injectors when they're firing, because they are pulsing. So they create electromagnetic waves. This then obviously then can absorb all of those pulses, and again, it keeps noise out of things like your cam and crank trigger. It's also sometimes used to keep noise out of the radio. Sometimes you can hear like a hissing or like pulsing in the radio. The speakers obviously can pick up on that. So again, that's what that does. The capacitor is again designed to basically absorb all of that extra voltage and take it back to ground again. So that's where it's on there. It's on a metal bracket, so it's actually going to ground through the inlet manifold. Right, what you'll also notice on these, which is really nice from Toyota, is they've color-coded the injector plugs. Now obviously this harness, all injector plugs were fully intact and fine to need replacing, so that was great. But you'll see they are gray and brown, gray and brown, gray and brown, which is fantastic. That's exactly what you want. So again, it's really, really easy to know which one is 1, 2, 3, 4, 5, 6. You should end up with this particular pattern where it's gray, brown, gray, brown, gray, brown. Now, obviously, the lengths do kind of dictate, because obviously this one is not going to go over there. This one would go over there, but this one wouldn't go over there. So you'd quickly figure out that you had it in the wrong place. Okay. But that's all that comes out over there. We then get into our next piece of plastic, which is, again is bolted down there and there. Super simple, nothing too major there at all. And from here, there is actually a section that breaks down and goes through there. So we're going to go through that in a minute. We're going to carry on with the rest of this first. But we have injector 3 and injector 4. Super nice and simple. Moving along to the back here, a couple of things that break out to the back here. We're going to have this, which is our purge valve. So again, that is on the intake manifold. And it's this little valve over here that plugs into. Okay. Then we've got injector 5. We've got our cam sensor, which goes over there, and we've got injector 6, okay? So that's that. This is where we started adding stuff in. So again, because this is going to go manual, we've removed all the automatic gearbox wiring from the ECU entirely. You can see that plug is almost bare now. That's all the automatic wiring goes. And we've replaced that with a harness for a manual gearbox. So again, nice and simple, all labeled up, little 4-pin DTM connector there. And down at the bottom there, you can see there is our reverse switch. And just going to quickly move over. And there is our speed sensor switch. This one's using a J160 gearbox, okay? But of course, the reason we put the gearbox harness on a sub harness is so that you can basically use whatever gearbox you want. Phone us up, we'll make you a different harness if it's R154, different harness if it's a W58, different harness if it's a BMW, etc., etc., etc. But anyway, that's why we did that. So you weren't limited, or you'd have to make any alterations if you wanted to change the gearbox, okay? Right, so that's the top section of that done. Nice and simple. So let's make our way down over here. And I'm gonna, hopefully you can see, but you can sort of see it popping through over there. Sort of goes through there. You can see the actual plastic frame goes down and it pops out over there. And while I'm here, I did actually miss this, I'm sorry, but there is an earth strap over here which bolts onto the inlet manifold over there. Remember, this inlet manifold comes in 2 sections. You've got this section which is bolted to the head, and then the section down at the bottom, which I've been videoing, is the section that goes onto this and goes over the top that has a throttle body on. But anyway, out of the section here, you've got an earth strap, so that bolts on there, again with an M6 bolt, so 10mm socket on that bad boy. And also on this side over here that pops out there, you have another earth strap over there. Again, M6 bolt, 10mm socket, off you go. Okay. So again, this sort of splits out almost immediately. You've got two sections there. That one is the earth that goes over there. This one is for the ACIS, vacuum solenoid valve. So ACIS is acoustic control induction system. So technically it basically varies the intake runner length. And obviously when we do the testing, you'll see I do the ACIS testing. So again, you'll see that is actually working, okay? This section that pops down over here is going to go for a little bit, and then it's going to break out into two sections. One is your starter solenoid, so that's going to plug directly into there. Again, I can't really get all the way down there, but it's again standard to have a starter solenoid plug in there. Then I'm going to try and get around here, but as you can see my fingers pointing to the gray connector there, that is your secondary knock sensor, okay? So that's knock sensor for bank 1, which is over there. So Toyota classify cylinder 1, 2, and 3 as bank 1 and cylinder 4, 5, 6 as bank 2. Okay, if you're interested. So that is how they work it there. Right, so that's done now. So let's move along and make our way over here. Okay, so again, piece of plastic goes down into there. It does bolt down over there. Little sort of Allen cap over there. I think that's the standard one that comes on there. But the only section that breaks out over here is just the coils themselves. Okay, so you can see here, you've got one that comes out immediately and goes to that coil. Then you've got another one that goes along, breaks out, goes to that coil. Another one goes along and it goes to that coil over there, okay? Now, as you can see, there's only 3 coils. So obviously the 2JZ VVT-Is are running a wasted spark system. Same with the GTE VVT-Is, also a wasted spark system with these 3 individual coils. So basically the way this actually works is kind of weird and people do get confused. But this one at the back here is on cylinder 6, but it runs along here and it goes to cylinder 1. So technically speaking, in terms of outputs, this is going to be IGT1, okay? Because it's going to fire 1 and 6 first, right? Then this one over here goes to cylinder 4 and makes a little loop over there and goes to cylinder 3, okay? So this one is actually 2, okay? Because that's the second, this is actually IGT3. So this is the third one to fire, again, because it's cylinder 3. Now then, this one that goes at the front here is actually on cylinder 2, and its little lead runs all the way along there and goes over to cylinder 5, okay? So that's actually 2. So it's 1, 2, 3. That's how the engine's firing. 1, 2, 3. So it's firing 1 and 6, 2 and 5, 3 and 4 at the same time. So hence you get the term wasted spark, because one of the sparks that is happening is actually wasted. It's on the exhaust stroke, okay? But that's how this system over here works. So you've got 3 coils and each coil goes directly over a spark plug, and then you have an HT lead that runs to the other one to fire the other spark plug at exactly the same time, okay? So again, that's why it gets a bit confusing, because you would think 1, 2, 3, but it's not actually the case. It's 1, 2, 3, okay? So hopefully you got that. 1, 2, 3, okay? Right, so moving along from that, before I bore you to death, plastic goes around here, comes out over here and goes down over here. So let's carry on down here and see what we've got going on. So harness runs down along here. It's a lot thicker than a GS300 because it also has the main alternator cable. So that bolts directly onto here. No dramas there at all. 12mm socket, undo the old one, or undo the nut, bolt this down and bolt it up again. Also coming out here is your crank sensor. So that's that one over there. Also coming out here is your alternator plug. So that plugs directly into there. Also coming out here is your bank 1 sensor 1, okay? So again, that runs down there and goes over to there. So again, bank 1, 1, 2, 3. By the way, if you ever buy these aftermarket manifolds, they're not really great because you're only actually measuring cylinder 2. So if something happens on cylinder 1 and 3, you'd never know about it. And your ECU can't compensate for it. So not a great design for an aftermarket manifold, but they were cheap enough and I bought it for the startup engine. Right, so that's that. And then lastly, coming out here is gonna go over to your MAF sensor, okay? So, little caveat with the MAF sensors when it comes to the 2JZs, and this obviously applies to the various different models. On the GS300 in Europe, basically there were 2 versions. There was a 98-01, which came with a rectangular style ECU, and that had what I call the bullet style MAF. So it was the much bigger MAF that looks like a bullet basically inside it, okay? Then from 01 to 05, there was a couple of changes. Number 1, on the GS300, you had shift up, shift down, okay, for the automatic gearbox. And then they also moved to this style of mass airflow sensor. Now, this mass airflow sensor and the bullet mass airflow sensor have different wiring, okay? If you wire it for one and plug in the other, I think one way, anyway, it blows up the intake air temperature sensor because it sends like 12 volts straight down it. And it goes straight to earth. So basically be very, very careful with GS300s because obviously you can have 2 types of MAF sensor. And the annoying thing in Europe, which doesn't apply in the United States, but the annoying thing in Europe is they kept the exact same ECU shape between 9801 and 01 and 05. So you can't tell just by looking at the ECU. You have to look at the part number and you have to determine whether or not yours was a earlier one or a later one. On the IS300s, it's really nice and simple. In Europe, they only did one model. It was that, came with the wedge-shaped ECU, and they all used this style of mass airflow sensor, okay? So nothing really to worry about there. It's the GS300 you got to really worry about in Europe. But in America, they didn't have that problem because in 01 to 05 on the GS300, they also changed over to the wedge-shaped ECU. So just to make your life more fun, depending on where your ECU is from, it can have multiple differences. So again, that's why it's super important to determine exactly what you have. And the best way to do that is to look at your ECU part number. Forget about the harness because the harnesses look almost identical, so you wouldn't be able to tell the difference from there, but make sure that you have got the correct ECU for your harness, okay? So if you have a bullet style MAF with your harness and you check your ECU and it comes up to an 03, there's a problem there. Someone has done something wrong there, or the ECU has been changed out on the older harness. So just make sure that you are aware of that, guys. Super, super important. There is one other issue, the change over on the GS300 that you could sort of help to tell you is that basically on the earlier 98 to 01s, they had an oil pressure switch, which was a single wire one. And on the 01 to 05s, they had, same as the IS300, an oil pressure, actual proper 0 to 5 volt sensor. Okay. So again, you can kind of tell what harness you've got on a GS300 by that is kind of your best guess on what the harness comes from, whether it's from an early model or a late model one. Again, with the American guys, doesn't really matter. You got different ECUs, so you'd always be able to tell the difference between it, okay? Right, so that's that section over there. So moving along here, we then have the plug for the drive-by-wire throttle, which again, once the throttle goes on, you'll see it just plugs in directly over there. We then have our accelerator position sensor plug. This is the 4.1 over here, and that goes over there to the accelerator position sensor. And then lastly, we have our Lambda sensor for bank 2, 456, sensor 1. So you see that one is over there again. So again, brilliant design. If anything happens on cylinder 4 and 5, you ain't gonna know about it. But on cylinder 6, that's where it's reading the Lambda from. Okay. Right, so that is basically the entire engine harness and how it is laid out. Now, the nice thing with this one is, in reality, all that you kind of have to add on is basically your earth. So again, you would normally have a bar that runs from here down to the block over there. I think that's where the earthing point is on these. So again, that would run from there to the negative of your battery. Now, on your vehicle at the moment, whether it's an IS200 or an Altezza, you'll see this cable, which basically goes down under the battery, bolts to the chassis, and then it does actually pop out down here. And I think I cut mine, or someone cut mine. It's been pulled and yanked a bit, so it doesn't really work as an earth strap anymore, so I don't use it. So I've got my own little earth that I've connected directly to the battery over there, but that's what you guys would be using. This one that goes straight down under to the chassis and then straight to the block. The other earths that you want to connect are going to be from one of the gearbox bolts to the chassis leg. You'll see there's normally like a what I call a braided earth. So it's not insulated with anything. It's just literally like a piece of metal braid. And it goes on your gearbox bolts and it goes straight to the chassis. So again, that's going to help with your starter motor over there. So technically the one that goes to the block is for your starter motor, but that one would also help with your earthing at your starter motor. And then lastly, on the engine at the back over here somewhere, there's usually a bracket, and then you can take an earth from there to the firewall. Now my bracket's missing because it would be like a vacuum boost sort of pipe that goes along here. But on your firewall here, or if you had an original sort of RS200 3SG or a IS200 1GFE, there'd be an earth strap going from there to the cylinder head. So those are the three earths that I recommend you connect to. I just love earths, so don't feel bad about connecting loads of earths up. You're doing yourself a massive favor. Next up is going to be your main power for your starter motor. So again, you can see that's bolted on there, and that in my case goes directly onto there. Now, do be careful with your fuse box over here. You'll see there's a little cable that runs from the fuse box and it goes over there. So this goes over there, and if you're using your starter motor cable from your IS200 or whatever, you'll actually notice that it actually goes on top of this and bolts down. Okay, so again, please make sure that you put this and your starter motor on there, because this is the power for the entire car. If you don't connect that, nothing is going to start up and run. Okay, right. In terms of your fuel, again, if it's an RS200 or a 1GFE, they all run a returnless system, which is exactly the same as what the IS300 with the 2JZ and the GS300 ran. So you should have one single fuel pipe to connect up to here, and that should be really, really nice and straightforward. Okay, right. And that's basically it. So what I'm going to do now is I'm going to go away. I'm going to get the intake back on again. We're going to pop back. I'll show you where those other connections go when it's actually on the engine, and then we'll jump into the testing. So see you in a second. Right guys, so now we're back again and we're here for the testing part of the video. And as I said, we've now got the intake and throttle body on there. So I'm going to quickly go through the connections on there just so you can actually physically see them. Obviously I went through them earlier, but so you can actually see where they plug in. So starting at the back here, we do have our noise filter plugged in over there. Really nice and simple. TPS is plugged in over there. That's a little 4-pin connector over there. We have our accelerator position sensor that plugs into this. Remember, this is drive-by-wire. So you can actually hear there's no connection to the actual throttle blade until you get to the end. There you go. So it is drive-by-wire. So that's an accelerator position sensor, and that is a TPS sensor, and there's your motor for the throttle body itself. Then we have our Lambda sensor for bank 2 sensor 1, so that one goes over there. We then have our drive-by-wire motor plug over there, so that has the 2 wires, positive and negative for the motor, as well as the clutch. So there is actually a clutch in here to disengage the throttle if there was an error, so that's how they did the safeties on those particular throttles. There was one other section I didn't cover, and obviously doing this Lambda is brought back to me now, is we have remapped the ECU to obviously remove the secondary Lambda sensors. So this ECU does not require secondary Lambda sensors, the ones that are after the catalytic converters. So you're only required to fit bank 1 sensor 1 and bank 2 sensor 1. That is it. That's all that's required for this particular harness. No more cat errors or the P0421, I think, code that you get when the catalytic converters go. Or if you're removing the cats, if you're able to legally, obviously you won't get a code for that either. Okay. Right, so now then, what are we going to be testing in the video? So as I said earlier, we're going to be testing 2 sections with the ignition on and with the engine running. So I've got a quick list down here. We're going to go through that and I'm going to show you exactly what we're going to be testing. So first of all, immobilizer removal, which we have removed as part of the remap. Now, obviously, an Altezza doesn't have an immobilizer system at all. So unfortunately, I can't show you like the security light flashing because obviously the Altezza wouldn't have that. So the test for that is basically going to be when the engine starts up. So obviously we know that the immobilizer is removed. So I've just noted there, Altezza, no security light, so you can't see the security light turn off when I put the key in. Ambient temperature, nice and simple. We're just going to go over here to the climate control and we should see our ambient temperature displayed on the dash over there. That's basically all we're looking for. In this particular case, it is actually connected to the outside temperature sensor, so it will go up and down as the temperature goes up and down on the outside. Then we've got check engine light and charge light. So again, that's going to be on the dash here. So we should have our check engine light at the top there. We should have our battery light down there. And we try to make sure that they turn on. And obviously when we start the engine, we do things like look at the tacho to make sure it's working. So you'll actually see that those do turn off when the engine is actually running. Oil pressure, I've noted down here that because it's an Altezza 300 it actually has an oil pressure gauge. I don't have an Altezza 300 cluster, so unfortunately I don't have that gauge. It's one of these gauges over here. And so therefore I cannot test that. So obviously I just check that manually with a multimeter as part of the harness process, okay? Then we have reverse and speedo. So basically all I'm going to do is imitate what the reverse connector or the reverse switch does in your gearbox. So I'm just going to bridge this here with a wire. I do it at this end over here, so it tells me the crimp on the terminals and the wires and everything inside the vehicle is 100%. And we're just going to listen for the beep that you get on an Altezza or an IS300 when it goes into reverse. It tells me that this, from the connector all the way into the car, everything is correct and working properly. Speedo, as per usual, I've got my little device here to output a speed signal. So we're going to connect that and we're going to make sure the speedo goes up and down just to make sure that is working correctly. OBD2 test, basically what I'm doing now is, again, we're using the new GTS Plus system from Toyota. Again, I can go through that, guys, if you want, but it's a nice subscription service. You don't have to be a dealership to use it, but you basically get the equivalent of TechStream, Toyota's new version called GTS or Global TechStream. I'm just using a Tatrix open port 2 cable over there to the OBD2 port that's inside the vehicle. So remember, with these plug and play setups, in this particular case, you're just using the standard OBD2 port that's inside the vehicle. There's nothing fancy. We're not adding anything in. Unlike the later 3UZ version where it actually switched from K-line communication to CAN, in which case we actually put a OBD2 port in the ECU box so you can connect to that one, because there's no CAN communication within this vehicle. There's MPX communication, but no CAN communication. Right, and then we're going to test the fuel pump relay, AC clutch. We're going to check the AC request and the brake switch, and that's all going to be done with the TechStream over here. So basically what we're going to do is use the TechStream to activate the fuel pump, because in this case the fuel pump is controlled by the ECU. Down in the description I have a bunch of videos about things like how the fuel systems work, etc, etc. So please, if you go down, you'll see a bunch of useful videos there, shorter videos that go into more detail about particular things like the fuel pump, like the ACIS, etc., etc. AC clutch and request, that's going to be super easy. I'm going to use the check stream to activate the magnetic clutch relay. So we'll hear the relay click in the corner over there. That tells me that everything is 100%. And then AC request, I have it on the live data here. So all I'm going to do is press the AC button, and then it's going to say AC request is either off or on. And that tells me that the MPX data, because things like the AC request are actually transmitted via MPX, which was an early version of CAN, to the ECU. So as long as I press the button and on here it tells me AC request is active, then I know that that data is being transferred correctly. Now do remember, as part of the AC system, everything has to be connected as per standard. So again, as per IS300 Altezza, you need the pressure switch, you need the whole lot for it to work. It'll work completely as factory, okay? And brake switch, again, I explained the relay earlier over there, so we're imitating the 4-wire brake switch. So all I'm gonna do is provide 12 volts to the brake switch wire, which would normally come from the car. The relay is going to click, and we're going to come over to the computer, and it's going to tell me the brake switch is either off or on, and that's all we need to see. In terms of the engine running, first of all, the starter circuit, well, that's nice and simple. Basically, we want to make sure that when we put the key in the ignition, that we turn the ignition and the engine starts. That tells me that the neutral start switch has been bypassed. Now, yes, obviously, even on the manual versions of that, to keep the wiring the same, there's just a loop in that gray plug. And that sort of loops the neutral start switch. So when you have a manual version, you have a loop. When you have an auto version, that actually goes down to the gearbox, to the gear selector, and it tells it when it's in park or neutral. And again, I do have a video about the differences between park, neutral switch, and gear position. If you are interested in that, you can go and take a look at that as well. Then the ACIS. So what I'll be able to do is, again, go onto TechStream. I'll be able to then activate the acoustic control induction system. And what we're looking for is this thing to move, okay? So that's gonna move, and that's basically what we are looking to happen. Drive-by-wire test, well, that's gonna be super simple. I'm just literally gonna come back over to the vehicle, and I'm going to rev it. So all I wanna do is just do a slight touch like that. And the reason that is that I know that if I do a slight touch and it revs up, I know that the drive-by-wire system is working exactly as expected to. If I was to turn that throttle and it did nothing, and at the very end started revving, I would know the throttle is not actually working. Oil control valve VVT-i test, basically we can do it via the tech stream. It effectively retards and advances the CAN. Now, obviously, if the engine is going to be cold, it might stay running. If the engine is slightly warmer, it'll actually cut the engine out. Don't be worried about that. That's exactly what we would expect to happen if we tested the oil control valve. So again, we're just testing that to make sure that it is actually working. And this is the oil control valve over here. So this is how the CAM advances and retards. So remember, these engines only have a VVT-i on the inlet side, not on the exhaust side. So hence you only have one oil control valve. Next up is injectors and coils. So basically what I'm gonna do there is I normally leave the injectors not fully pushed on. And what I try and do is remove each injector one by one, and therefore you can hear the engine misfiring as I do that. And the reason I do that is obviously to make sure that all the coils and injectors are firing as they should do. So when it's up and running, it should be nice and smooth. When I remove those one by one, you'll hear the engine misfire. It tells me that each cylinder is firing correctly. Then tacho, so what we're going to do is we are going to come back to the cluster over here. We're going to make sure that our tacho is working. We're going to make sure that our coolant temp is working. So normally what I try and do is get it up to about sort of 40, 50 degrees. That's when the needle starts moving. And as we do all the other tests, basically what's going to happen is the coolant is going to go up, and you will then see that. So we'll start off on a low, we'll do all the tests, come back, and you'll see the coolant would have moved up to a higher position. Then what we're going to do is the diagnostic. So again, because of the remap, the way I've got it currently set up here with everything connected, like the two Lambda sensors, the MAF, everything is connected. So we should have absolutely zero diagnostic codes on this ECU. And that'll be evidenced by the check engine light turning off when we start the vehicle, okay? And that's what we want to look for, making sure that we have no automatic gearbox codes because they were all remapped out. Make sure we've got no secondary Lambda codes. Basically make sure we've got absolutely zero codes at all, because this setup is plug and play. And if a check engine light comes on your dash, it means there is a problem that does need to be resolved, and not something that's a byproduct of removing the auto gearbox or doing the swap or anything like that. Okay, right, so first of all, what we're gonna do is let's jump in with the ignition on testing. And as it is plug and play, the way you would do it in your vehicle is plug everything in. You would grab your key, you would turn the ignition on. Very, very simple. Again, we can't check the immobilizer light, so I'm gonna leave that and move on to the next one, and that's gonna be the ambient temperature. So let's move along to there, and you can see that we have got 12 degrees on there, perfect, which is about right. We're getting into winter now, so it is a little bit cold in here. And next up, we do have check engine light and battery light. So there's our check engine light in the top there. There is our battery light over there. Now, quick note while I'm here, anything to do with TRC or traction control or VSC obviously doesn't work with these swaps. So please make sure that you guys do remove any TRC bulbs out of your dash. Specifically in this particular case, a IS300 had VSC. Normally the Altezzas and the IS300s has TRC, a totally different system altogether with a whole different bunch of sensors. So again, yeah, they can't talk to each other effectively. Not to worry too much, TRC is a very basic system. It's basically just shuts the throttle down if it detects wheel slip. So, but again, because they can't talk to each other, because VSC is much more complicated, it has things like steering angle sensors and so on, it's just not going to work basically. Okay. Right, so that is that. A check engine light, charge light, again, oil pressure light. We know we can't test it, so let's jump over and let's do our reverse light. So again, I'm going to try and do this single-handed. But again, all I'm going to do is bridge these two together. And you can hear that beep going on over there. So again, I always test it by pushing a wire in there because I want to make sure that even the crimps on the terminals are correct and strong and not loose. So that's why I do it in that particular case. After that, we're going to do the speedo. So again, I am just going to probably have to put you to one side for now. And let's get this device working. So bear with me 1 second. Again, very tough single-handedly. Right, fantastic. Okay, so again. Right, so this is a good test because this is what we call a Hall effect style sensor. So pin 1, which is over there, is 12 volts, hence the red wire. The middle one is ground. So again, I'm using that and it's displaying now that I have a flashing light on there. I know that there is power and ground going to the switch. And again, same principle as below. We are literally testing at the plug to make sure that even the crimps on the terminals are correct. So as I touch the yellow in there, you can see there, sorry, it's not super in focus on the plug, but you can see as I touch the signal there, the speedo goes up. So that is absolutely perfect. Okay. Right. So do bear in mind with these style speed sensors on Toyota vehicles, whether it be Altezza, IS200, etc., when they came as a manual, obviously the signals go through the blue plug over there into the vehicle, but the ground is actually coming from the cluster to avoid ground loops. So obviously if your cluster is not grounded correctly, that could be a reason why your speedo is not working. But again, a nice little tip for you guys when you are setting everything up. If for whatever reason you don't have speedo, a nice, quick, easy test that you can actually do is obviously to unbolt the speed sensor at the back of the gearbox. Basically tape the little gear on the end to your drill, get your friend to turn the ignition on, you spin the drill, and let's see if we get some speedo. If you do get a speed signal when you turn the actual speed sensor with a drill, then clearly there's something wrong inside the gearbox and that gear is not turning, obviously, when the gearbox is turning. If you spin that drill and you still get no signal, that's when you would start looking for an actual electrical issue, making sure that things like the dash has all the correct power supplies to it, making sure no fuses are blown in relation to the dash. But if you also get no reverse lights and no speedo, just remember that 12 volt source for the reverse light and the speedo come from the same place. So again, if you don't have a speed signal, check reverse. If you have no reverse, then go look for that fuse. There'll be a fuse blown in that particular case, and that's why you won't be getting a 12 volts to either your reverse light switch or your speed sensor. Okay. Right, so after the speedo, we got OBD2 test. Well, because this machine takes so long to connect, I have already connected up to it here. So I'm just going to go in and I've actually set down a much more sort of condensed information to sort of speed up the process of the data coming through. So you can see there we do have our intake air temperature at 15 degrees and we have our coolant temperature at 13 degrees. Again, this engine's been cold. So again, that makes perfect sense, but we are getting signals coming through. So now that we've got that, let's jump into the rest of it. So now we're going to do the fuel pump relay. So what we want to do there is we want to go over to active test. And we're going to come down here to fuel pump relay and fuel pump. If you watch my fuel pump video, you'll understand exactly why that is there. So let's open up that active test. And what I'm going to basically do is keep quiet now. Hopefully you can hear the pump running. You can turn it off. All right, fingers crossed you heard that, but yeah, I can hear the fuel pump running there, so that is absolutely perfect, and that's exactly what we want to see there. After the fuel pump, let's go over to the AC clutch. So while we're in here, we can go over to AC magnetic clutch relay. We can turn that on. Now again, I'm gonna have to be quiet because effectively there's a relay inside here, that little fuse box over there. That's where your AC magnetic clutch relay is. So I'm gonna have to try and turn this on, and I'm gonna keep quiet. Right, so hopefully you heard that, because I do actually have the AC pump connected electrically, so you can actually hear the AC clutch engaging on the AC pump as well. All right, AC clutch, let's go down to AC request. So now we're gonna go off active test. We're gonna go onto data list, and again, my sort of narrowed down information is much easier to see. So we'll go into testing there. Now at the moment you see AC signal is now off. So let's go ahead, pop over to here. Turn that AC on, and now our AC signal is now on, and we'll go turn it off. Okay, and AC signal is now off again. So basically the car will tell the ECU when it wants AC. The ECU still has some level of control, so it will not turn on the AC clutch if it doesn't have any pressure in the system, either too high or too low, etc. So all those safeties are still in place, because that's actually taken care of via the ECU, not by the vehicle. The vehicle just says, I want AC. The ECU goes, right, all these conditions are met. Yeah, I'll turn it on. All right. After AC request, we've got brake switch. So at the moment you can see here, I've got stoplight switch over there. It is now on off. So again, I'm just going to go over to here. And this is the wire that would normally be your brake light switch coming from the vehicle. Give it 12 volts, and you can hear the relay click over there. And now our stoplight switch has gone to on. That's fantastic. So let me pull it out again. You can hear the relay click away there as well. And now brake light switch is off. So that's exactly what we want to see. Okay, so what I'm going to do now, because obviously it's very loud when the engine runs, because of the way the ACIS system works, you actually have a vacuum canister that does actually hold a vacuum. Now, fingers crossed, I have been running the engine quite a bit earlier on. So there's your canister. That actually holds a vacuum. So I should, theoretically, be able to test the ACIS system right now. So if I go over to active test, and obviously it's called the intake control vacuum solenoid 1. I'm gonna pop into there, and let's activate that. Okay. So you can see there now that that is actually pointing downwards. I'm gonna try and hold the camera there, turn it off. There you go. Okay, so I'm actually happy already that the ACIS does work. I'll go through that anyway as part of the testing with the engine running. But again, I just wanted to show you guys now while it's quiet, while you can hear everything and see everything. Right, so that is the testing with the ignition on. Now we're gonna move to the testing with the engine running. Again, what I am gonna do is, because it's only 13 degrees, I'm gonna try and get it a little bit warmer so that the temperature does start to display on the dash. And once that happens, we are gonna pop straight back, and then we'll jump into the testing with the engine running. So for me, a couple of minutes, for you, 1 second. See you soon. Right guys, so now we're back again for the engine running testing. So again, you'll see I've let it go up to about 51 degrees. So we're kind of just over the first line over there. It's just enough away from the needle that hopefully it'll go up in temperature as we do all the testing. So quick recap, I'm not going to go in detail. So starter circuit, again, just want to turn the key, make sure she starts. ACIS, we're going to make sure that that little valve there actuates as we expect it to. Again, using the computer. Drive-by-wire test, rev the engine. Oil control valve, again, on the computer. The engine might die, but that's perfectly fine. Don't stress if it does. That's actually a good sign, so that's working. Injectors and coils, I'm going to remove each injector one by one. There is one in the middle, which is number 4, that is very difficult to get to with the intake on, so I might be able to get to that one. But if I do the other 5, I myself have physically tested it, but if I do all 5, then and the engine's running smooth, process of elimination, that one's obviously working just fine as well. Tacho will come back and we'll make sure that the tacho is working. Again, don't worry about the accuracy because this is a 6-cylinder and I've tried to adapt it to a 4-cylinder clock, which is what will go into the Altezza. Coolant temp, we want to make sure that that goes up from where it is currently. And diagnostics, we're going to make sure that we haven't got any codes related to the engine. So I'm going to get my ear defenders on and hopefully you can hear, but let's get it started up. So again, 3, 2, 1. Fantastic. Okay. So starter circuit, all good. Immobilizer is obviously removed. ACIS. So we'll do the active test. We'll go back to the intake control vacuum solenoid valve. ACIS, let's go over to drive-by-wire. Super happy with that. Let's go over to oil control valve test now. So we'll get out of this one. We'll go into VVT-i control bank 1. So again, that's what it's going to do. Okie dokie. That's perfect. As I said, I'm probably going to cut out, but it did do that. Right, injectors and coils. So let's go over to here now. Let's start with injector 1, injector 2, injector 4 quickly. There you go. Number 5 and number 6. Fantastic, that is perfect. And let's go over to the tacho. So again, you'll see the tacho is working. Give the engine a quick rev. So that's perfect, and obviously the coolant temperature, as you can see, it has clearly risen from the lowest point over there. Okay, right, so let's go into our DTCs. Now obviously we've got no check engine light, we've got no battery light on there, so that is exactly what we would expect. And actually what I'm going to do now is I'm just going to disconnect the fuel pump, so I can do that very easily. Perfect. Okay. Right, so obviously we've got codes because of what I did. So again, we've picked up cylinder 1, 2, 3, 4, 5, 6 has a random misfire. It is a pending code because obviously I just disconnected the injectors for a short amount of time. So again, but more importantly, we have absolutely 0 codes for gearbox, automatic gearbox. We have 0 codes for secondary Lambda sensors. And obviously because the engine started, we know the immobilizer has been removed, okay? So again, these are obviously because of all the testing that I do. Okay, again, this is a much more involved or in-depth system compared to the little handheld device that I used to have. So again, it has picked up a misfire, which is pretty good. It's what I should expect because obviously I did make all the cylinders misfire and it did pick it all up there. Okay, so diagnostics, super simple. We haven't got any of the codes that we were expecting because obviously we removed the automatic gearbox, okay? So again, you'll see that the check engine light was off the whole time it was running, and that is perfect. That's how it should be in your setup. There should be no reason the check engine light's on. If it is on, there is a problem that you need to resolve, obviously, before you can then go ahead. So you need to plug in your diagnostic machine like this, get your codes, and see where your issue is. So again, diagnostics, standard OBD2 port that's inside the vehicle. Nothing fancy, nothing more than what you did before with your Altezza 300 or your IS300 Lexus. Again, exactly the same process. Now, in terms of diagnostics, there is some other bits and bobs that you can do, okay? One that can be particularly useful for you is you can actually check the timing of the engine with a timing light via the diagnostics port. So if you see down here, you'll see you've got 15, 10, 5, and 0 degrees. Obviously, I've made 10 white because when I'm doing aftermarket ECU or standalone ECU, I will set the timing at 10 degrees before top dead center. And that's obviously the timing that I'm looking for when I use my timing light. But On the older IS200s, this one particular is between a 98 to 01. You have this diagnostic port on the front of the engine bay here by this fuse box, okay? It's a very simple diagnostic box. You can't plug into it, but there is the ability to have access to what we would refer to as TE1 or TC, which is that one over there. So it's that one in the middle over there, and E1, which is over there. Now, what you can do is you can actually then bridge those two terminals together, and it'll put it into diagnostic mode. Now, unfortunately, with the IS300s, you can't do the flashing of the check engine light, which you can with the IS200, so you can't get the codes the old-fashioned way. So that's a bit of a bummer. So you will have to plug in a diagnostic machine to actually read the codes, okay? But going into diagnostics mode does not only involve things like reading codes the old-fashioned way by the flash and check engine light. Once you put into diagnostic mode, you will actually lock the timing of the engine at 10 degrees, okay? So you can bridge the terminals there if you've got that in your particular vehicle. If not, on your OBD2 port plug here, pin 4 and 5 are grounds, and pin 13, I think, is TC. So again, you can take a paper clip or something and you can just bridge those two pins together. Your dash will start to go crazy. It'll start flashing your ABS light and all of that type of jazz, because obviously it puts the whole system into diagnostic mode. But obviously with that is the engine as well. If you do that and you start the engine up, it'll lock the timing at 10 degrees. So all you basically got to do is take a timing light, wrap it around cylinder 1 HT lead over there, and then you can go down there and you can see my white mark over there and the 10 degrees there. Now, on a JZ engine, there's actually two marks, so do be very careful. One of them is white, one of them is yellow. The yellow one is actually for doing timing belts, so it's to put the engine at a certain thing so you can change timing belts. So please be wary of that. There is the specific one for that, and what you can do is obviously you still have your marks on your cams there, so you can pop this cover off the top. You can then rotate the cams till you see the marks line up there, and then the marks on there and there, okay? And then you should obviously be able to run the engine, use a timing light, and make sure that that timing mark is at 10 degrees, okay? So if you have a suspicion that your timing is out and you're not 100% sure, that's a nice, quick, easy way to test it. And obviously if it is out of time, then you can pull off all the covers on the front and then you can check the timing there. Now, there is one other thing that I would like to bring to your attention, especially working with these older engines over here, is your timing marks are on your damper pulley, which is there on the front of your crank. So it's the crank damper pulley, okay? Now, the outside of that and the inside of that is joined with a piece of rubber. Now, that's important because over time, as it ages, that rubber can get old. It can delaminate from the metal there, okay? So again, the marks behind the pulley, if you pull that off and you actually have marks on the block itself, those will be your definitive marks, okay? Because they're never going to move, okay? So if you find that your timing is out and you check the timing and all the marks line up, but the crank doesn't line up and it's slightly out, you still might want to take that off, check the condition of the pulley in the front, and then once you have that off, you can actually line up the marks on the block with the marks on the cams at the top, and then you can be 110% certain. I just bring that up because obviously you guys don't want to chase a red herring. If you do that timing and you find, hey, it's out by a few degrees, and it turns out that actually all that's happened is your pulley damper, the rubber is delaminated and moved ever so slightly, as opposed to you actually being out of timing. So just a little caveat I want to throw into there, okay? Right, so guys, that is pretty much it for this particular harness over here. So again, we're going to get this boxed up, get it off to the customer, let him plug into his car, and let him start riding, okay? If you guys have any questions on what we've gone through tonight, please feel free to let me know. You can comment down below. You can find us on Facebook, Phoenix Engine Management, and you can send us a message there, or you can email us at info@phoenixenginemanagement.com. If there's anything you'd like to know specifically, you can go there. If there's anything you'd like me to cover that I haven't covered that you can think of, please let me know in the comments. I'll try and do individual videos on smaller subjects that are obviously broken down into much shorter videos. But again, down in the description, I've got a bunch of these videos. I have a playlist called The More You Know, where I fill that with pieces of information like how the fuel pump system works, what the ACIS is, how to check timing with the timing light. I've got all of those videos in there, so if you want more detail, you can have a pop at that playlist and go through it. But I'm super happy with this. Everything is working as it should. ECU communicates as it should. Engine runs absolutely fine. So I've got no problems at all. And again, we have tested the customer's igniter. The only thing we haven't tested, obviously, is his mass airflow sensor. So again, if you might have an issue with that, but obviously really easy to diagnose. And obviously I do put a bunch of part numbers down at the bottom so you guys can find the correct parts for your particular engine. If you want UZ part numbers, go to a UZ video. If you want 3UZ, go to a 3UZ video. Look in the bottom there and you'll see a bunch of part numbers for a whole host of things that I recommend people change when they're doing conversions. But Thanks for watching, guys. We'll see you again soon. Bye-bye.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life, I never miss, that's fact, taking big swings, put your hand to the bat, put me in the ring, you'll go out in a bag, cause I sing what I mean and I bring it to the mad light, ain't got time to kill, I got time to feel, I took the red pill, I know life's short so I wanna live real, but how's it supposed to feel?